Hey guys, welcome to the RDS tutorial from Scaler. So I'm Kodishwar and I'll be taking you through this comprehensive RDS tutorial. So RDS is basically relational database service. We'll be learning how to create a relational database on the AWS cloud and how to connect to it and start working with it. Okay, so now before moving on with this particular session, please make sure to subscribe to our channel so that you do not miss our upcoming videos, and also leave a like if you enjoy our content, and also leave a comment if you have any queries, and we would be addressing them all so that we could reach out to you even in a better way. All right, so now without any further ado, let's begin with this session. So guys, let's start off by understanding what is Amazon RDS. So first of all, Amazon RDS basically means relational database service. So it's Amazon relational database service. It is a tool. It's a service provided by AWS where you can create and operate and launch basically a relational database on the cloud without having to set up anything meticulous. Okay, so it's pretty simple. You can just start. You can just log in and create a database in a couple of minutes. You don't have to basically launch a server and install all the necessary software. For example, let's say you want to set up a MySQL server. In that case, if you're going to use a normal server, in that case, you will have to install MySQL in it. Once you install MySQL, then you'll have to configure it. You'll have to set up the authentication methods. You'll have to create users. You will have to do a lot of configuration before it can be used, right? But let's say there is a service called Amazon RDS where everything is already available. You'll just have to put in the information and create it, and it'll automatically create a database service which is already hosted on the cloud for you in a couple of minutes. So that's exactly what Amazon RDS does. So Amazon RDS is a web service that makes it easier to set up, operate, and scale a relational database in the AWS cloud. So RDS, using it, it's pretty easy to set up a database on the cloud. Directly from the cloud, you can operate it, you can modify it, you can delete it, you can stop it, you can reboot it, and also scale. Scale is increasing the size of the database. Let's say initially you've given 30 GB of the storage. Let's say you want 300 GB. You can do that with just a couple of clicks. Let's say if you want to increase the compute size of your database server, compute size in the sense making it more powerful. Let's say if the database server is running on an instance which is of like 6 GB RAM, now we want to make it 32 GB RAM. So in that case, you can do that using Amazon RDS again with a couple of clicks. Okay, and also it provides cost-efficient, resizable capacity for an industry standard relational database and manages common database administration tasks. So the best thing is it's not just for a simple database project. You can use RDS for large scale company wide major projects as well. You can use it for live projects. So it has the ability to scale itself according to the incoming data, and also it's cost efficient. It's much cheaper than your other counterparts. Like let's say you want to set up your own on-premise database server, it's much cheaper than that. And also it manages the common administrative tasks like minor version upgrade. So let's say you've chosen MySQL. If there is a minor upgrade which has to happen today or tomorrow, you can set this. You don't have to do anything. AWS themselves will do it for you. And also, why do you want to run a relational database in the AWS cloud? So why do you want to run a relational database? Because AWS takes over many of the difficult and tedious management tasks of a relational database. So that's why you'll have to take up. But what are those tasks? And how does it compare to a regular server which has RDS running inside of it? So that's what we're going to see right now. So let's compare EC2 versus RDS for cloud relational databases. So we've already seen EC2, right, in the EC2 tutorial. So EC2 is basically a service which can give you an instance. An instance is basically a server on whichever operating system you choose. For example, if you need a Linux server, you can create one. If you need a Windows server, you can create one. So that's what EC2 does. So once you create, let's say, a Linux server, in that you can set up a MySQL server, right, using Amazon EC2. So in this case, the thing is, for a relational database in a non-premise server, you assume full responsibility for the server. So not only the database server, you also have to manage the server itself. The server has to run in order for the database server to run, right? For a database on an Amazon EC2 instance, AWS manages the layers below the operating system. In this way, Amazon EC2 eliminates some of the burden of managing an on-premise database server. So you can use Amazon EC2 and basically install MySQL server inside of it and configure it according to your needs. This is one way of launching a relational database. The second way is to use Amazon RDS. It does everything for you. It's responsible for most of the management tasks. It eliminates all the tedious manual tasks. You just have to focus on your application and its code and how to make the database even better. That's it. RDS takes care of everything else. So now, Amazon themselves recommend RDS over EC2 for relational databases. So let's see why. So this is a basic comparison between Amazon EC2 and RDS. So let's say if you're launching a relational database on EC2 and if you're using the RDS service for the relational database. So what you will have to manage and what AWS will manage. So if you're using Amazon EC2 management, in that case, application management, scaling, high availability, database backups, software patching, OS installation, all of this should be managed by you. You would be selecting the operating system. You would be installing the software. You would be patching the software. You would be updating the software. You would be updating the server. So all of that tasks fall on your hand. And also you will have to maintain the database server. You'll also have to maintain the application which the database is connected to. So all of these tasks will fall on your hand. But if you're using EC2, obviously the maintenance of the server, AWS will handle. Hardware lifecycle, AWS will handle. So the rebooting, terminating, if you're doing anything, all the hardware tasks, AWS will handle. The power, network, cooling of the servers, everything, AWS will handle. Okay, so this is EC2. But let's say it could be much easier than this. In that case, you should go for Amazon RDS. So if you want to launch a relational database on the AWS cloud, in that case, obviously you'll have to go with Amazon RDS. Okay. So only application optimization. Application optimization is basically writing your code in order to make sure the queries are running faster than normal, making sure that your application can retrieve and write in a lot of data without having to wait for the next query to come in. Okay, so all of that. So now, in this case, Amazon RDS, you will only have to manage the application optimization, scaling, high availability, the patching, the installation, the server maintenance, everything will be handled by AWS. So I think obviously RDS would be the right choice, right? If you want to go with cloud relational databases, you don't have to manage anything else. You just have to create it. AWS will manage everything else for you. Okay, so that's why you'll have to go with RDS. So let's look into the RDS concepts. A database instance, a database engine, and a database instance class. So first of all, a database instance is basically an isolated database environment in the AWS cloud. The basic building block of Amazon RDS is the database instance. So how in EC2 you have an instance, right? So it's basically an instance is a server. So in this case, a database instance is the database environment which is created. So that's the most integral concept. That's the most basic building block of Amazon RDS, because without a database instance, you cannot do anything. Once you create a database, you would get a database instance. So that's what so a database server is what called as a database instance in this case. Okay, and then comes a database engine. So a database engine is the specific relational database software that runs on your database instance. Amazon RDS currently supports the following engines. So database engine is basically the relational database software. So database instance is the server in which the database engine is running. And the database engine is a database software which you can choose from. So there are totally 5 different engines available in Amazon RDS: MySQL, MariaDB, PostgreSQL, Oracle, and Microsoft SQL Server. Okay. These are the 5 database engines, database softwares which you can choose from to run on RDS. There is one more which is called Amazon Aurora, but Amazon Aurora is not exactly a database engine. It's again a database concept which RDS themselves have launched. But again, in that case, in Amazon Aurora, you get 2 options to choose from. You can choose MySQL or PostgreSQL. Again, so while we see the demo, I'll be explaining about Amazon Aurora. It will be much easier to understand over there. But for now, you can just imagine that there are only 5 different database software which you can choose from in RDS. Okay, and then a database instance class determines the computation and memory capacity of a database instance. So now, when you launch an EC2 instance, you select an instance type, right? The instance type basically decides the memory, the storage, the computation, all that of the EC2 instance. So the exact same way in this case, you can select the database instance class. Basically, the database instance class will have the computation and memory capacity of the database instance. For example, each instance type offers a different compute, a different memory and storage capabilities. For example, if you're using a database.m6g is a general purpose database instance class powered by AWS Graviton 2 processors. Okay, so this is basically one type of database instance class. There are various types. Again, we can see that in the documentation. And while we are looking into the demo, we're also looking into the database instance classes. All right, let's move on to the next slide. Okay, so now we've seen the basic RDS concepts. All right. Okay, so now Amazon operates state-of-the-art high availability data centers. Data centers are basically the availability zones which AWS provides for you. Although rare, failures can occur that affect the availability of the database instances that are in the same location. For example, let's say you are launching a database instance and you have multiple databases in the same location. So if you host all of your database instances in the same location, let's say if there is a failure in that particular availability zone, none of your database instances will be available. For example, in this particular architecture, database instances are available in this one particular availability zone in the entire region. So in that case, if this availability zone has a power outage or some random disaster or it goes down, in that case, you don't have any backup databases and your application wouldn't be working because the only database engines which you had, which are in one particular availability zone, are down now. So to basically combat this, you can go with basically a concept or an architecture called multi-availability zone deployments. So in this case, you can have one or two standby database instances. When the deployment has one standby database instance, it's called a multi-AZ database instance deployment. So a multi-AZ database instance deployment has one standby database instance that provides failover support but doesn't read traffic. So what that basically means is this is the primary database instance is available in one particular availability zone. So this is the database instance which basically interacts with the clients. So the clients are basically, let's say if there is an application and that application is connected to this database and I'm the user trying to access some information from the database, and when I do that, it gives me the data back from the primary database instance. So now let's assume that the availability zone, so this particular availability zone is not available. Okay, so now there's a standby replica, right? This particular replica will start working. So in this case, once this is, if there is a trouble here, it will fail over to this particular database instance. So now any connection which is coming in will go to this database instance. And once this is not available, then this database instance would act like the primary database instance until this availability zone is back up again. Okay, so that's exactly what happens. So if this goes down, there would be another database to provide failover support in that particular meantime so that your application is still performing and running. So this is basically a multi-availability zone database instance deployment. There would be one standby database. There is another thing called multi-availability zone database cluster deployment. So in this case, there would be multiple database instances. So for example, in one availability zone, there would be the writer database instance. So the writer database instance is the only instance in which you can write and read. So both things could happen. And then in the other two availability zones, they have two reader database instances. So reader database instances are only there for reading. Okay, you cannot write into these databases. You can only read from these databases. So a multi-AZ database cluster deployment has standby database instances. It's not just two. You can have any number of standby database instances that provide failover support and can also serve read traffic. So it cannot serve write traffic. It can only serve read traffic. Only the primary database instance or the writer database instance can also serve read and write traffic. The reader database instances can only serve read traffic, but also let's say if this particular database instance goes down, you can set up a priority. A priority will decide which database instance will become the primary database. For example, let's say you have two database instances in two different availability zones ready for failover support. So if you provide the priority for this particular database as 0 and this particular database as 1, so this database has a higher priority than this database. So if this writer database goes down, this database would be made the writer database or the primary database until this availability zone or this database is back up and running. Okay, and in the meanwhile, this particular database will still be able to provide read traffic. It will serve read traffic. It will not serve write traffic. Only this database will provide write and read traffic. So the replication will be going on constantly. So let's say if I'm writing some data, it will be immediately replicated into these reader databases. Same thing happens here. If new data is written into the primary database instance, there would be synchronous replication going on. As soon as there is data available, there would be little to no latency. The data would also be available in the standby replica. Okay, so this is basically the different architectures which you can go ahead in RDS, and there are still more architectures which you can create by yourself manually, but these are the commonly used ones, and these are the default available ones. You don't have to create them, you just have to select them. It will automatically create these architectures for you in AWS. And let's look at the final slide before moving on to the demo. RDS pricing. So Amazon RDS provides the following purchasing options, especially two purchasing options like the EC2 instances: on demand and reserved. So on demand is you create a database instance whenever you want and you pay by the hour. Okay, so pricing is listed on a per hour basis, but bills are calculated down to the second and show times in decimal form. RDS usage is now built in 1 second increments with a minimum of 10 minutes. Okay, let's say you're launching RDS instance and deleting the RDS instance in 2 minutes, but you will still get charged for the first 10 minutes. Okay, so that's the minimum charge, but after that you will get billed based on the seconds you've used the database for. So if you've used it for, let's say, 40 minutes, you will only get charged for the 40 minutes you've used. If you used it for 2 hours, you will only get charged for 2 hours. And that's on-demand instances. And the bill will vary according to the instance class you choose, the database instance class. If the RAM is higher, obviously the cost of that particular instance class will be much higher than a smaller instance class, right? So that will also depend when it comes to billing. And second option is reserved, a reserved database instance which you can take up for a year or 3 years and get a significant discount. So if you are paying upfront for the complete year, it will be much cheaper. You will get around 45% discount. If you're paying for the first 6 months, you will get again like around 42% discount. So it'll totally vary. You can talk to the Amazon AWS sales team. They would give you the offer. And it'll again depend on what kind of a plan you're taking up. If it's a 3-year term, the discount will be much bigger. If it's a 1-year term, it will be a smaller discount, but it'll be much cheaper than the on-demand instances if you are going to use the database for a complete year. So with reserved instances, you can launch, delete, start, or stop multiple instances within an hour and get the benefit of reserved instances benefit for all the instances. So what exactly happens here is these reserved instances are dedicated for you in dedicated physical hardware, and you can start and stop them whenever you want because you already paid the money for them. Or you can also pay them in monthly, or if you don't want to pay any upfront costs, you can also pay them monthly or pay them at the end of the term. Okay, so these are the different types of pricing models in Amazon RDS. So that's it for the theoretical part, guys. So now let's move on to the demo and understand and basically create a database and connect to it. So guys, let's start off with the RDS demo. So we've understood the theoretical concepts. So next we'll be moving on to the demo. So now first let me introduce you to all the existing components in the RDS dashboard. So the first one is the dashboard itself. So in the dashboard, you can see again what are the resources available, the database instances which are available, and then the database clusters which are available. So the difference between database instances and clusters: database instances are singular databases. Database clusters are a cluster of multiple databases put together, which act as one single unit. Okay, and reserved instances, again, if you have bought database instance for a year or 3 years, that would be a reserved instance. Snapshot, if you've taken backup, there would be snapshots. And if there are events, parameter groups, option groups, subnet groups, so basically all of the information which you need about the RDS dashboard, about the RDS tool, will be provided over here. Okay, coming up next would be the databases. So here you will be able to see all the databases, all the database clusters, every single thing would be available over here. And then query editor. So query editor is a tool which you can use to basically connect to the database which you've created and basically run some queries. So you can be if you want to practice queries, if you do not have a database client in your local laptop, then you can use the query editor to do that. And then performance insights. So this performance insights will exactly show, for example, if you once create a database, and you can select the database over here, and it will give you metrics which will tell you how the database is performing, and also how you can improve the performance of the database. And snapshots, again, this is for backup. Uh, then there are two types of backups: manual backups and automated backups. You can enable automated backups, and it will automatically back up the data in your database in frequent intervals. If it's manual backup, then you'll have to take a snapshot of the database. So you'll have to click here and select the database and then take a snapshot, and then it will basically create a backup of it. Okay. And so you can use the backup service. Again, you can export it into Amazon S3, so you can do a lot of things with this. And then there is a reserved instances. We are not purchasing any reserved instances, but again, if you want to purchase a reserved instance, it will provide you a dedicated database instance for a year or 3 years or however long you have purchased the instance for. All right. And finally, proxy. So you can again create a proxy which would basically be in front of your database, and you don't have to provide actual endpoint details to your database. You can use the proxy details, so that would give you an additional level of security. So then there are subnet groups. So these are the subnet groups which will be created when you create a database. Parameter groups will be attached to the database. So what happens here is, so every parameter group will have a set of instructions, will have a set of parameters, and that parameters will decide how the database will function. So every single parameter group will have information. For example, so you can see this, right? Allow suspicious UDFS. So do you want to allow suspicious UDFS? So in that case, they have provided false, and then auto increment offset, they're provided as true. So then bin log format, they're provided as true. So these are different parameters which will decide how the database will function. Will it allow certain types of IP addresses? Will it not allow? What would be the total cache size be? So all that. So that can be modified over here. But the thing is, if you're using the default group, you cannot modify it. You can create a parameter group, a custom one, like the custom ones which are available here. You can create your own custom one and then attach it to your database. All right. Okay, so now let's go back to the dashboard. Let's now connect. So this particular tutorial is a pretty simple tutorial. We will be creating a database, and so once we create a database, I'll be showing you how to connect it to and how to log in into the database from the query editor and how to run some simple queries. Okay, that's what we're going to look into in this particular session. Because if I show you how to connect it to the local database client, so in that case everybody should have it downloaded. But if you do not, most probably you wouldn't have it downloaded. Most of you would be beginners, so in that case I would basically suggest you to use the query editor which is already available. Okay, so now let's start by creating a database. So first thing, click on create database. Okay, so there are two options: standard create and easy create. Standard create will give you all the options which you need to basically enter. Easy create will automatically fill in most of your details. You can just select whether it should be production or it should be dev or test type of database. So production will cost you more, dev or test will cost you lesser than that. But again, in standard create, you will get another option that is free tier. But my free tier is over, so my account was created like 2 years back, so I don't have the free tier enabled. So as I told you, my free tier is done, so that's why I'm not able to see that. If not, if you've just created your AWS account recently, so in that case you would get an option production dev/test, and one more option would be free tier. So under free tier, you do not get charged anything for using the database. Again, you get 750 hours of database runtime every month for the first 12 months after you've created your AWS account. So it would be free, guys. If you've not created your account, just create your account. You can practice for free. I'm going to go with dev/test. And so the thing is, with standard create, you can select the type of instance. So you can select the available version you want. You can see they've provided you with all the information about the available database engine versions. You can select it should be provisioned. You need your servers created, or it should be serverless for you. So what kind of replication do you want? Do you want it to be a single master? So supports multi-reader instances connected to the same storage volume as a single writer instance. So this is a good general purpose option for most workloads. So basically there would be one single master with multiple readers. So let's say there are 5 readers and one master. In that case, the master database is only used for writing, and you can also read, but it's essentially used for writing data into. But the rest 5 databases, which are reader nodes, in that you cannot write any data, but you can only use them for reading. So that is single master. And then multi-master, again, you would have multiple masters which are connected to the same storage volume, and you can also have multiple readers. So this is basically for continuous writing. So if there is data which will get often inputted in your database, if there is always data incoming to your database, in that case you should better go with multi-master. So if it's more of a read intensive application, then single master would be fine. But if it's a write intensive, if it's for analytical purposes, if data is being fed into your database, in that case multi-master would be much better. Okay, so then you can select the engine type. So again, over here, engine type is the first option. So I'm going to go with MySQL. Amazon Aurora is a type of database which is provided by AWS, as we've already discussed that. So over here, you can see Aurora provides 2 options. You can select MySQL compatible edition and PostgreSQL compatible edition in Amazon Aurora. So it's not a separate database of itself. It's a database engine where you can use other database editions to start with. But mostly it is basically a type of a database architecture which will be much better. So as I told you, you can select from single master and multi-master. So this architectures will automatically be enabled using Amazon Aurora. You don't have to do anything else to basically create these architectures. You can directly start off with these architectures without even having to basically starting to create each one. For example, let's say you are creating a reader, then you're creating a master database, then you're creating multiple databases. You're basically creating this complete architecture by yourself. So you don't have to do that all by yourself. Instead, you can just use Amazon Aurora in order to do that. But right now, let me create a MySQL database. Next, I will show you how to create a Amazon Aurora database. So you can select MySQL, MariaDB, PostgreSQL, Oracle, or Microsoft SQL Server. So any database you want, you can select it. And then you can select the version over here. So over here, you can see I have a free tier option, right? So I can select the free tier, but even then, one thing you have to know is in Amazon Aurora, there is no free tier option, but in the other database engines, you have free tier. But another thing is, even though I click on free tier, it will select the cheapest option for me. But again, it will get me billed. That cheapest option also will have a bill, so that will get billed. But the thing is, if you have your account which is created under 12 months, in that case, it will be free for you. So you don't have to worry about it. So then I'm going to leave the database instance identifier as database1. So everything else is fine. So I'm just going to leave the database identifier as database1, the database username as admin, and I'm going to give the password to log into the database. And here you can see there's only one type of instance available, only one instance type available, that is db.t2.micro. So this is the only available instance type which is under free tier. So if you click on free tier, it will automatically get selected. You won't get the option to select any other instance type. Okay. And then you can select what type of storage you want. So it could be general purpose or it could be provision IOPS. So provision IOPS would be more expensive option than general purpose. So for practice, you can just go with general purpose SSD. You don't need flexibility in input output right now. Then magnetic, it's not recommended. So I would just go with general purpose or provision IOPS. Okay. And then storage auto scaling, I'm going to deselect this. So the thing is, why do you need storage auto scaling? So let's say if you have a database, if you do not know how much data is going to get into your database, in that case, you can enable storage auto scaling. And over here, you can see this, right? So maximum storage threshold. So you can basically provide a maximum threshold for your database. It could be from 21 GB to 16 GB. So, sorry, 16,384 GB. So you can provide 16,384 GB as well. So what is basically this? So this is the storage your database can maximum store. So that you can provide over here. So the auto scaling, even though it's auto scaling, the maximum it can auto scale would be up to 16,384 gigabytes of data. So if it's 1000, in that case, 1000 would be the maximum threshold of data. So there could be 1000 gigabytes of data which can be stored. Okay, so allocated storage is already 20 GB. So allocated storage would basically be the dedicated storage which is already connected to your database, which is already created to your database. Okay, after that, if you want more data to be included, you can enable auto scaling. So again, as this is a practice, I'm not going to enable auto scaling. We don't need auto scaling for this. And then I'm going to leave the VPC at default. I'm going to leave the subnet group as default. So public access. So let's say if you want to connect your database to external PC, so like my local PC or a EC2 instance. So to do that, you can give public access. So if you do not give public access, so only the EC2 instance which are within this particular VPC can connect to your database. So if there is an EC2 instance in your default VPC, that can connect to your database, but it will not be assigned a public IP address. So if it does not have a public IP address, in that case, you cannot connect it to a local client like my laptop or any other EC2 instances in any other regions. Okay, so I'm going to make it public access as yes, and existing security group, you can create a new one, or you can just go with the default one. It doesn't matter. And then availability zone, you can select an availability zone, or you can provide no preference. So it will choose any availability zone you want to, so automatically. So I'm just going to give no preference. All right, and the next one is database authentication. How do you want to authenticate into the database? So there are three options. There is password and IAM authentication, there is password and Kerberos authentication. The simplest method is password authentication. So IAM authentication will basically provide you IAM users. You will have to authenticate by providing the IAM the database password and the IAM users username and password, and you'll also have to create a role. But in my case, I'm using the root account. I'm not an IAM user. I'm not a user in this account. I'm the root user. So in that case, I don't need IAM database authentication. Then password and Kerberos authentication. If you want to use Kerberos, you can go with that. But for now, as this is a practice and as you have to understand, I'm just going to go with password authentication. Okay. And the additional configuration. So if you want a database already to be created in your RDS instance, so you can provide it over here. So if you do not want any database, don't provide any name over here. It will give you a blank database server. So in that you can create any database you want. But I want a database created in my account in my database engine. So I'm going to provide a name as practice. So once this database is created, there would be a database called practice created inside of this database instance already. So you don't have to create another database. You can create another one, but I'm saying that you can already initialize a database before even you log in into the database you created. And then you can enable automated backups, and I'm not going to enable automated backups. You can enable enhanced monitoring, which will cost you a little more. But again, right now you do not need enhanced monitoring. But if you are creating a project in which you need to monitor every single aspect of the database to understand how you can make the database perform even better, then you can go with enhanced monitoring. Okay. And then maintenance, enable auto minor version upgrade. And then there is a maintenance window. So you can enable this. So whenever there is a minor version upgrade to the database engine, it will automatically run it and it will automatically update it. You don't have to accept anything. And then maintenance window, no preference, and enable deletion protection. So the thing is, if you enable deletion protection, it will not let you delete your database automatically. You will have to go into your database, modify your database's configuration and disable this particular thing. You'll have to disable deletion protection, only then you'll have to delete it. Otherwise you'll not be able to delete it. But again, right now I don't need that. So I think everything is being provided guys properly. So I hope you guys have noted it down. So first select the database engine type, then select the version type, then select what type of template you need. Go with free tier for practice. So again, I just wanted to show you one more thing. So let's say if you're going with production, so in that case, you have another one. There is multi-AZ and single database instance. So what does this mean is, if you use single database instance, it'll create a singular database instance in one availability zone. If you're going with multi-availability zone database instance, it will create a primary database instance in one availability zone and a standby database instance in another availability zone. So if that one availability zone's primary database instance goes down or is not working properly, the connections will automatically be redirected into the standby database instance, which is in the other, which is in the other availability zone. Okay, so this is basically production again. So same thing will come in dev test, but I'm going to go with free tier. So everything else is the same, guys. You don't have to change anything else. So over here, provide the database name, provide the username, provide the password. This will automatically be chosen if you've selected free tier. Select general purpose, select the storage, select the connectivity, so default VPC, default subnet group, public access. Again, the VPC security group is also going to be default. I'm not providing any availability zone. I'm going to leave it as the same. It's going to be password authentication. So you will not be given this password again. So you should remember this, or you should note it down somewhere. And I've provided the name of the database, and I'm using a default parameter group. I'm not using custom one. Again, I'm using a default option group. So this is enable auto minor version upgrade. So if this is enabled, disable it. And if automated backups is enabled, disable it. That's it. So then you can just click on create database and it'll start creating the database for you. So it will take some time to create the database, guys. You can see over here, right? Your database might take a few minutes to launch. So this is the username and password which I've created. So this is the only time you will be able to view this password. Copy and save the password for your reference. As I told you, you will not be able to see the credentials once the database is launched. So make sure if you're given a tough password, make sure you'll write it down somewhere, or you log it into some notes or something in your laptop so that you won't forget it. But mine is a simple password and a simple username, so I remember that. So I'm just going to use that. So once the database is created, I'll be connecting to the database using the query editor. Okay, and then we'll be running certain queries and checking if the database is working or not. So in that case, we would have successfully created a RDS database. So this is the regular database, guys. So let me show you how you can start creating a Aurora database, Amazon Aurora one. I'm not going to create one. I'm going to show you how to create, but you can create it if you want to. So again, go with standard create, select the engine type as Aurora. So if you are familiar with PostgreSQL, go with PostgreSQL. If you are familiar with MySQL, go with MySQL. Okay, and then select if you want it provisioned or if you want it serverless. So you specify the minimum and maximum amount of resources needed, and Aurora scales the capacity based on the database load. So this is a good option for intermittent or unpredictable workloads. So let's say you have an application in which you often get sudden spikes in traffic, or you get unpredictable workloads. That is, let's say for an hour you have 1,000 users, then the next hour there are only 10 users, and for the next 2 hours there are 10,000 users. So sudden increases and decreases and changes. So in this case, you can go with serverless. So it will automatically provision for you. You don't have to worry about provisioning database servers. And then select the available version type. Okay, and then select the template if you're going to use it for testing. Environment, go with dev/test. If you're going to use it for production, go with production. So, and then give the database name, give the username, give the password. Okay, and then here you will get the option to select the database type. So you can select whatever database type you want. You can see the virtual CPUs, you can see the RAM. If not, if you want a burstable instance, then you can go with the burstable instance. So again, you can select, you can see everything right over here. So again, if you want to see the cost of these instances, just open the RDS documentation and go to the pricing part, and you will find the prices of each and every database instance class. And then you will have this option, so multi-AZ deployment, and don't create a Aurora replica. So what happens is, once you create a database using Amazon Aurora, So you can create replicas of your databases. You can create a reader node. Okay, so there would be one primary database instance, and there would be multiple reader nodes in Amazon Aurora. So what basically happens here is there would be one primary database, and that primary database can be used for writing and reading, and the rest of the which are called Aurora replicas or reader nodes can only be used for reading data. You cannot write data using those reader nodes. Okay, so that's basically it. So there is nothing else complex here. You can create a replica when you're creating the instance. So it will create a primary database and it will create a reader database once you are launching the instance itself. But if you don't need if you don't want a replica, you can just select this. It will only create a primary database. Later, once you've created it, then you can launch more replicas of the same database. Okay, so why it is called a replica? It's called a replica because it will have the same data. It will basically have the same storage volume as the primary database. So you don't have to rewrite anything into the replica. The data is already available in the volume, in the storage volume. You are just connected it to the replica. So it's just reading the same data which is being written into the primary database. So in that case, there would be no latency between copying data into the replica. Okay, and then select the VPC, select the subnet group, select if it's public access or private access, then select the VPC security group, and then select what type of authentication you want. So in this case, there is no password authentication. You can go with IAM database authentication or Kerberos authentication. Password authentication is always enabled, so you don't have to basically select any one of this. You can select this if you need it. For example, if you wanted to more you want to protect the database even more, then you can go for IAM database authentication. If not, you can go for Kerberos authentication according to your requirement. But in this case, I don't need both of them. And then here you can see more additional information. Again, it's the same information. That is, you can provide the database name. You can have backup. You can enable encryption. So performance insights. So performance insights will give the performance insights of the Aurora database. So I already discussed, right, what is performance insights over here. Yeah. So then monitoring, then there is maintenance. So you can basically provide all of this, guys, if you need. If not, you can just deselect all of this. For example, enhanced monitoring, you can deselect, and then enable performance insights, you can deselect. Yeah, so pretty much that is this is just additional configuration. And so the database has been successfully created, it seems. We'll go see that. So this is how you can create an Amazon Aurora database, and it's very similar to creating a regular database like we just created. So if you click on create database, it will create one for you. Then you can start using the Amazon Aurora database. The only difference would be the architecture of the database, but the connection, everything would be the same. Okay, so the database has been created, guys. Let me open this and show you what are the things which would be available in the database. So the first option would be connectivity and security. So the first option is endpoint. So endpoint is basically like the public IP address of this particular database. So using the endpoint, you can connect to the database from wherever you are in the world. If you have internet access, you can connect to it. Port number is 3306 and public accessibility is yes. And the availability zone which it has been created is US East 1F. So all access is available inside, all access is available outside. So basically you all incoming traffic from any IP address is available. Outgoing traffic from any IP address is also available. So that's what this particular security group tells you. Okay. So again, you can create a proxy for this particular database as well. As I told you, if you do not want to provide, so you can select the database. You can provide the identifier over here. Okay, you can create a proxy for this database if you do not want to provide the actual details of your database to, you don't want to mention it in a code, or you don't want to give it to someone else. You can create a proxy and give those details to the person or in the code. Okay, so now we are back to this. Okay, so then there is monitoring. So monitoring will basically show what is the CPU utilization, how much memory is available right now, what is the input outputs, write and read input output, free storage space which is available, how many database connections has been made. So as of now, 0 database connections has been made because we've just created the instance, we've not connected to it. And CPU utilization will basically show how much, what is the percentage of CPU utilization. Over here you can see it went up to 45% when the database was creating. So right now it won't be utilized much because it's at a standstill. There is nothing going on in the database. Then logs and events. So whatever happens in the database, all the logs will be available here. You can come back over here and check it. If there is an error, that log will also be available here. You can come back over here and download the log and check it, or you can just view the log directly from here. Okay, and then there is configuration. So these are the configuration details we provided, guys. So all of that will be available here. And maintenance and backups. So we've enabled minor version upgrade, but we have not enabled what is that? Yeah, we've not enabled automated backups. We've disabled it, right? And then later, if you want to take a snapshot is basically taking a backup of your database. You can do it manually over here. And then there is tags. So we've not provided any tags also. So one more thing is that going to actions, you can stop it. You can reboot it, or you can delete the database instance. And then there is create Aurora RAID replica. And so this will basically create a RAID replica of this particular database if you want it. But right now we don't need a RAID replica. And then take snapshot. Take snapshot is basically create backup, and migrate snapshot. So migrate snapshot will basically copy this snapshot into another region or into another availability zone in order to create a database over there. Okay. And then modify instance will basically take you to the modification wizard, where you can change the current details of your database and then continue. So that will basically modify the details. For example, if you want to make it private, so if you want to change the instance type, if you want to change the master password, if you want to create a standby instance, if you want to change the authentication type, if you want to enable what is this, if you want to enable deletion protection, you can do this from here. So this will modify your database instance for you. Okay, so we've created a database successfully, guys. I hope you guys also have followed through and created a database. So now let's connect to the database. So to connect to the database, I'm going to open the query editor. Okay, so query editor over here, let's see if it's automatically connected to the database. Currently query editor only supports Aurora serverless databases. Only Aurora serverless database that you have access to will be displayed. So the thing is, okay, so that basically means you cannot connect your regular database over here. Okay, so before they used to provide access to all kinds of databases, but now the only access is available to the Aurora serverless databases, to the MySQL community databases or PostgreSQL or MariaDB databases. The access to the query editor is not available, and performance insights won't be available as well because again we've not enabled performance insights for normal databases. Okay, so what we're going to do is we're going to install MySQL in my local PC, and we're going to connect to this particular database from MySQL. Okay, so to do that, let me open the terminal. Okay, so to install it, it's brew install MySQL. So we're installing MySQL in my local PC so that we can connect our database which we've created to it. So it will take a couple minutes. So that will be done soon. So let's wait until it installs. Then I'll show you how you can connect the AWS database to the local client, and then how to query from your local client. Okay. So guys, as you can see, MySQL has been successfully installed. Okay. So so to connect to our local MySQL, we can use MySQL -u root. So this would be more than enough to connect to our local client. So now we want to connect to our database, our AWS database, which has been created. So in this case, the username would be the endpoint, which is provided over here. So now let me just clear this, and let's try to, okay. So to connect to the local one, this is how you connect. So now let's see the databases which are available here, so that I can show you the difference between when we connect to the AWS database. So you would get the idea, right? So this is the local one. So these are the local databases which are already available. Okay. So let me create a database. Create database local one. Okay. So let me see the databases again. So now you can see, right, local one database has been created. Okay. So now let's connect So I'm going to exit, and now let's connect to our AWS database. Okay, so it would be MySQL. Username would be admin. Host name, so -h is host name. Host name would be the endpoint. Okay, and then capital hyphen capital P is port number 3306. Small hyphen p would be the password. So once you hit enter, we can provide the password. So the password for my database was admin123. So I provided the password, and now you can see I am connected to the AWS database which I just created. So you can see that, right? So now to confirm that we are connected to the AWS database, let me show databases. It will already have a database named practice inside of it. So we did not log in into the database before. We only logged into the database. So we only logged into the local database. We did not log into the AWS database. So this is the first time. Okay, so now you can see the practice database is available, and you can basically see the difference, right? The local one database is not available here because this is not the local MySQL client. This is the MySQL database which is running on AWS. So now again, you can basically create another database, create database test. Okay, so you can create another database, you can create another table, you can enter database data into the table. So you can do anything you want like a normal database client. So this is basically it. Then you can use the database tutorials from Scalar's YouTube channel. So there are SQL tutorials, right? You can open the SQL tutorial and use the SQL tutorial basics to do the exact same thing over here, because we've created the database, we've connected to it. Now all that remains is your SQL knowledge, and that's it. So now let me go over here, go to monitoring. So now you can see, right, database connections from 0 it went to 1 because we connected to the database one time. Okay, so that one time was right now. And freeable memory, again there is lesser freeable memory because we created another database, and CPU utilization has been around this. So it's been staying around 7.5% to 8%. Okay, so let me exit this again. So let's connect it to once more. So let's see. Okay, we've connected to it once more. So let's open the database connections, and over here you can see, right, value number 1 we've connected to it another time, and this is basically the real-time data which is being shown to you. So this is just the basic data, this is just the basic monitoring data. If you need more, in that case you can use enhanced monitoring. So there are more. So over here there is queue depth. So if there are queries which are in a queue, if you're using SQS, in that case you will see that over here. So read latency, how long it is taking to read, how long it is taking to write, what is the credit CPU usage. So basically, if you enabled enhanced monitoring, that you can see over here. If you've enabled enhanced monitoring, you can see every single OS process as well. So every single operating system process can be monitored using enhanced monitoring. That would give you much more detail into the database and what exactly is happening. If there is an error, you can easily identify what it is and rectify it. Okay, and you can, if you have another database engine, you can add that engine to compare to it, and you can compare how these two database engines are performing. And over here, let me just refresh this. So current activity, there has been 4.43% CPU, there has been one connection. So it will take some time to load over here, guys. And yeah, so this is basically it. So we've created a database successfully, and we've connected to the AWS database, which is running on the cloud server. We don't know where it is running. It's running in a data center in North Virginia, but we do not know exactly in what physical server it's running. We don't even have to care about it because we have all the details we need to connect to the database. Okay. Yeah, so we've connected to it, and that's it. So again, so to delete the database, it's again pretty easy. So just select the database, go to actions, and click on delete. If you want to create a final backup, you can create one, but if you do not need it, you can just unselect it, and then you can later select it, and over here, type delete me, and that's it. So it'll start the deletion process. and it'll delete the database. So this is basically it, guys. So that's it for today's session. Thank you. So guys, that's it for today's session. I hope this session was helpful and informative for you guys. If you have any queries, leave a comment down below and we would be helping you out. And also if you enjoy our content, please make sure to subscribe and also like and share our videos. Thank you.